Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into a cool lesson on factoring out the GCF out of polynomials, okay? And the whole idea is learning how to find the GCF first and knowing how to factor a number and a polynomial into what's called a factor pair. So what we're going to do is we're going to start off with what's called factor pairs, all right? And whoops, didn't mean to do that. All right, factor pairs, and here it goes. Every number or polynomial, all right, can be written as a product, all right, which means multiplication, okay, a product of two numbers. So for example, let's take 8 and let's start small here. Let's take some real numbers. All right, 8 can be written as 1 times 8, as you know. All right, you can always write a number as a product of 1 in itself. All right, and I always list my factor pairs from low to high. So that I can organize my work easily. So 8's even, so it's divisible by 2. So 2 times 4 is 8. All right, and there's no other whole numbers here that divide into 8. So the only factor pairs of 8 are 1 and 8, 1 times 8 and 2 times 4. Okay, those are called factor pairs. All right, pair means 2. All right, and these are called factors. That's called a factor. All right, and that's called a factor, and because you have 2 of them, it's called a factor pair. All right, so let's get some practice here. Let's take 20 now. All right, let's write all factor pairs. Always start with 1 times the number itself. All right, 20 is even, so it's divisible by 2 10 times. It's also divisible by 4 5 times. All right, and there are no other numbers that divide into 20 evenly or a whole number of times. And so these are your 3 factor pairs. There are only 3 factor pairs for 20. All right. All right, now you try 28, okay? Pause the video, try 28. All right, so now let's check your work. You have 1 times 28, you have 2 times 14, you have 4 times 7 as your 3 factor pairs. You know, some numbers only have a few, some numbers have many. And again, as the number grows and gets bigger, you might have more and more factor pairs unless it's prime, okay? But let's take some composite numbers, which are numbers that are not prime, like 32, all right? Try this one. Pause the video and press play when you're ready. Let's check your work. 1 times 32, 2 times 16, 4 times 8, and that's it. We only have 3 factor pairs for 32. All right, a little bit more challenging is 100. Okay, go for it. Pause the video. Okay, let's check your work. 1 times 100, 2 times 50, 4 times 25. There's 4 quarters to a dollar. That's how I remember that. All right, 5's divisible in that because it ends in a 0. So 5 times 20 sounds good because 5 times 2 is 10 and add another 0. 5 times 20 is 100. And guess what? 10 times 10, whoops, sorry, is also 100. So we have 5 factor pairs for 100. All right, something a little bit more challenging is 120. So try this one, okay? Pause the video, give it a shot. Okay, here we go. 1 times 120. It's even, so 2 times 60. 3 divides in there because 3 divides into 12, so 3 times 40. All right, since 3 divides into it, 4 divides into it, so because 3 times 4 is 12, so 4 times 30. All right, it ends in a 0, so 5 divides in there. All right, divides in 120 times and 24 times, so it divides into 120 24 times. All right. 6 divides into 12, so 6 divides into 120 20 times. And believe it or not, 8 divides in there 15 times, so 8 times 15 is also 120. And of course 10 divides into it because it ends in a 0, and 10 times 12 is 120. So it has 1, 2, 3, 4, 5, 6, 7, 8 factor pairs. All right, 8 factor pairs. Okay. So that's what I mean by factor pairs. So the only thing you have to do is learn how to do it with a polynomial, all right, with variables. And so what we're going to do is we're going to take it step by step, all right, and we're going to start talking about the GCF. And we got 3 groups here. So we got group 1, all right, group 2, and we got group 3. And notice that they're all different. The group 1 deals with only constants or real numbers. Group 2 deals with variables with no constants. And group 3 is a combination of the two. So we're building up skills. All right, so the first thing we're going to do is we're going to write the factor pairs for 24 and 32 to find the greatest common factor. All right, GCF, as you recall from middle school, is called the greatest, all right, which is another name for biggest. Common, that's the key word, so let's underline it. All right, factor. So what is the greatest factor that 2 or 3 numbers have in common? It doesn't have to be just 2 numbers, it could be 3 or 4. It doesn't matter how many, okay? It's a common factor, and you want to find out the smallest one with the greatest one, okay, because that's important. All right, so what we have here is 24 and 32, and so what we do is we take 24 and we write factor pairs for it. So this is equal to 1 times 24, 2 times 12, 3 times 4, 3 times 8. Come on, Ainsworth. 3 times 8, and 4 times 6. So we have 4 factor pairs for 24. Now for 32, we have 1 times 32, we have 2 times 16, we have 4 times 8. 4 times 8 is 32. And if you look at the list right here, you'll see that they have not only 2 in common, not only 4 in common, but the greatest one they have in common is 8. All right, and so we say that the GCF of 24 and 32 is 8. All right, there we go. And that, my friends, is one way to do it, is you list the factor pairs and you find the one that they have in common. Now, you may be able to do it in your head, mentally, and that is good. That means you're good at multiplication in your mind, and you can think about the factors. You know, what divides into both numbers, and what's the biggest number that divides into both numbers. Those are called factors, okay? All right, so let's take a look at 15. So 15 is 1 times 15, 3 times 5. All right, that's it. 35. These two don't have very many factor pairs. First one, 1 and 35, 1 times 35, and the second one is 5 times 7. And if you compare, we have the common factor. Whoops, I circled the wrong ones. Of 5. Okay, 5 divides into both of them, right? It's called a common factor. So the next one is 5. All right, GCF of 15 and 35 is 5. All right, now in the next one here, give it a shot. Pause the video and go for it, and then press play when you are ready. Go. Let's check your work. So 42 is 1 times 42, 2 times 21, all right, and 3 divides into it, because if you add the digits, 4 and 2, you get 6, and 6 is divisible by 3. So 42 is divisible by 3, all right, 14 times, all right, and then of course you have 6 times 7. For 18, you have 1 times 18, you have 2 times 9, and then you have 3 times 6. And if you look here closely, they have a 6 in common. There's a common factor of 6. So the GCF of 42 and 18 is 6. All right. Pause the video, try the last one. Okay. So let's take a look at it here. 28 is 1 times 28, 2 times 14, 4 times 7. 49 is 1 times 49 and 7 times 7, and so the common factor that is 7. All right, so let's get started here on the next group, okay? And you got to deal with some variables here, okay? So the way to understand that is by noticing something. So I'm going to do the first 2 examples, and I want you to look for something in common, okay? So what we're going to do is we're going to write out what x squared means. And x squared means x times x. And x, well, that's to the first power, so the only way you can write it is x times 1 maybe. And notice that they have a common factor, all right, of x. So the GCF of x squared and x is x. So the question is it always the one with the lower exponent? I don't know. So let's check. So let's take x cubed, which is x times x times x. Let's take x squared, which is x times x. And let's notice that they have not only one factor of x in common, but they have 2. So they have 2 factors of x in common, and guess what? That's x times x is x squared. They both have an x squared in common. All right, you can write x cubed as x squared times x, and you can write x squared as x squared times 1, and you'll notice that they have an x squared in common. So it is x squared for the GCF. And notice it's the one with the smallest exponent again. And that's the way it turns out. It's the GCF of 2 variables is found by looking at its exponents, and you choose the one with the lowest exponent, all right, which happens to be x squared, and over here it happens to be x. Let's write that down, the key concept here. All right, it's always, the GCF is always the one with the smallest exponent. All right, keyword smallest. All right, so when you compare this next one here, compare exponents here, x to the fourth versus x to the sixth. Notice that the x to the fourth has the smallest exponent. So this one here, the GCF is x to the fourth. Again, the smallest exponent. And then here, when you compare multiple variables, you look at variables one at a time. So you compare x squared with x cubed. All right, and notice that x squared has a smaller exponent. All right, 2 is less than 3, obviously. And then when you compare y to the fourth with y to the fifth, guess what? Y to the fourth here has the smallest exponent. So our GCF is x squared times, put a times there. All right, y to the fourth. You compare variables one at a time. So you compare the y's and then you compare the x's. All right, compare exponents. Let me write it down again. Compare exponents and choose the smallest one. Okay. Now, having said that, let's put the two concepts together here. So when you compare here, the GCF of 18 and 12, okay, is 6, not 2. All right, 2 divides into both of them, 3 divides into both of them, but 6 divides into them too. So it's going to be 6 there. You compare x with x squared, and x has the smallest exponent, so the GCF is 6x. All right, you can write 18x squared as 6x times 3x, and you can write 12x as 6x times 2, okay? And notice that this right here is in common, so it's called the common, greatest common, all right, factor. All right, because you can re-express the terms using that GCF. All right, here between 15 and 12, the common factor, or the greatest common factor, is 3. 3 divides into both of them. X squared versus x cubed. The x squared has the smallest exponent, so your GCF is 3x squared. Here, the GCF of 18 and 45 is 9. All right, 9 divides into both of them. All right, and you compare x squared to x to the fifth. The x squared has the lowest exponent. All right, and then here you compare 6 and 24. The GCF is 6. 6 divides into both of them. All right, and then x cubed versus x to the fourth. Well, let's take the x cubed because it has the smallest exponent. So once again, compare exponents. All right, choose the smaller one. Compare exponents. Choose the one. Oops, got to spell that correctly here. So choose variable, all right, with smallest exponent. All right, there's your little key concept here. All right, so having said that, here we go. We're going to start with the main lesson here. We're going to talk about factoring. And factoring, my friends, is multiplying in reverse. All right, so let me explain what that means. So you have to understand this crazy word called factoring because it's abstract. All right, so let me take real numbers, for example, so it kind of makes sense to you here. Let's suppose I ask you to take 2 times 9, all right? Obviously, if you multiply those two together, you get 18. All right, that's called multiplying. Nothing new. Okay? Now, when you reverse that process, all right, and you go backwards, and I say, hey, factor 18, you say 2 times 9. So the factoring is multiplying in reverse. It's going backwards. Given a number, write it as a product of 2 factors, which is called a factor pair. All right, which we just did right here many, many times. Okay, we just did it in the very beginning. We talked about factor pairs. So the question is you know, like, how do you factor polynomials? So let's say I ask you to take 2x times x minus 3, let's say, and I ask you to multiply these. All right, well, you distribute through. 2x times x is 2x squared. 2x times a negative 3 is a negative 6x. All right, that's called multiplying, distributing through. We've done that in our previous lessons, okay, extensively. All right. This time, however, okay, we are going to take a polynomial like 2x squared minus 6x and go backwards, okay? And when you go backwards in reverse, that's called factoring. All right. So if I ask you to take this polynomial here, all right, and write it as a factor pair, all right, notice this is a factor pair, 2x times, okay, x minus 3, that process is called factoring. And guess what? This right here happens to be the GCF. All right, so the question is, given a polynomial with 2 or 3 terms, or even 4 terms, how do you factor it into a factor pair? That's the whole essence of the lesson. And the question is, how do you factor out a GCF? All right, so let's get into it. And I'm going to obviously use the idea of factor pairs, because that's the whole idea. All right, so here we go. We're going to learn how to factor out the GCF, all right, using factor pairs. All right, so let me illustrate here. So let's take 18x and 4, and let's look at them here and think, what's the GCF of 18x and 4? All right, what is the GCF of 18x and 4? All right, forget you don't even have to worry about the minus sign right now, okay? That's irrelevant. So, and they're both even. So, what you can do is you can factor or re-express these as a factor pair. So 18, since the GCF is 2, I'm going to rewrite 18x as 2 times 9x. All right, 2 times 9x is 18x. And 4, well, that's just 2 times 2. All right, now notice that they have a common factor of 2. That's called the GCF. So what we're going to do is we're going to factor it out. Okay, and write it as a factor pair, a product of 2 things, 2 times something. Now when you factor out the 2, the remaining factors are 9x minus the 2. All right, 9x minus the 2. And so the polynomial 18x minus 4 is equal to 2 times 9x minus 2. And the question is, how do you check that? How do you know you're right? And there's an easy answer for this, and you just simply distribute or multiply through. So you check, all right, by multiplying, all right, which is called distributing, multiplying, which is called distributing, all right, through the GCF, okay? So you take 2 times 9x, well, that's 18x. And you take 2 times a negative 2, and that's negative 4, or a minus 4. All right, so you check by multiplying through. And if you're right, then you're probably on the right track. All right. All right, so let's get some experience here. You got to be thinking in your mind now, 55x and minus 11. What divides in 55 and 11? And, since 55 is 5 times 11, they have 11 in common. So what we're going to do is we're going to write each as a factor pair. So I'm going to write the 55x as 11 times 5x. I'm going to write the 11 as 11 times 1 because 11 is called a prime number. Okay. All right. So I notice that the common factor is 11. That's called the GCF. And that's equal to 11 times something, right? Well, that something is right here, 5x minus 1. So when you factor out the 11, the common factor, you get 5x minus 1 as a result. And you could check that. 11 times 5x is 55x, and 11 times a negative 1 is a negative 11. So you check by multiplying through. Okay, so let's get some experience here. Go ahead and pause the video and try the next one. Okay, so 4 and 6 are even. They're divisible by 2. So I'm going to factor out a GCF of 2. So 2 times 3x is 6x, and 4 is just 2 times 2. So notice that the common factor is 2, so I'm going to factor that out. So it's going to be 2 times something. And that something can be looked at or found by looking right here. So 3x plus 2. All right, 3x plus 2. So again, checking, 2 times 3x is 6x. 2 times 2 is obviously 4. Okay. Next one here, pause the video, try the fourth one here. Okay, 2 divides into 12 and 8, but also 4 does, and not 6, but 4. 4 is the GCF, so we're going to rewrite 12x as 4 times 3x. rewrite the 8 as 4 times 2. Those are called factor pairs again, factor pairs. And then I'm going to factor out the 4 because 4 is in common, right? Look right here, it's in common, so let's factor it out. Always start off with a GCF. 4 times something, all right? And you take a look at it, it's going to be 3x minus 2. 4 times 3x is 12x, and then 4 times a negative 2 is a negative 8. So 4 times the quantity, 3x minus 2. This process is called factoring out the GCF. All right, a very, very important concept because we're going to use it in all kinds of applications in the future lessons. All right, even next unit when we start solving polynomial equations, okay? Okay, next one here. What divides into 20 and 14? They're both even, so let's try 2. Okay, so 2 times 10x is 20x, and 2 times 7 is 14. So notice that I have a common factor of 2, so let me highlight it. Do that so you can see it better. And let's factor out the 2. All right, what do you get? 2 times 10x minus 7. All right, so we got 10x minus 7 right here. 2 times 10x is 20x, and 2 times negative 7 is negative 14. So you always check by distributing. Always check. All right, that's a check mark. All right, now the same process goes for group 2 here. In group 2, we got some variables in common too, if you notice. Okay, it's x squared minus 2x, not x squared minus 2. So on this one here, notice that there's an x in common. So I'm going to rewrite x squared as x times x, and I'm going to rewrite 2x as 2 times x, and you'll see that there's an x in common. Okay, there's an x in common. So let's factor out the x. And what do we have? We have x times x minus 2. All right, and let's check that. X times x is x squared. X times a negative 2 is negative 2x. All right, check by multiplying, as I keep on saying. All right, I can't impress that more enough because, you know, checking your work and seeing if it makes sense is important. There's no sense in doing a more complicated problem if you get step 2 wrong. All right, step 2 out of 5 will just not make your day, okay? So always check your work. So 4 divides into 4 and 8, and there's an x in common. So let's rewrite them with a 4x, okay, in common. So 4x times x is 4x squared. 8x is just 4x times 2. 4x times 2 is 8x, okay? And then you factor it out. Let's go for it. So we're going to factor out the 4x as a GCF and multiply it by our leftover factors, or what are called remaining factors, the x minus 2. Okay, so 4x times x is 4x squared. 4x times a negative 2 is negative 8x. All right, and you just keep on getting some practice here. So factoring the 9x squared minus 3x. 9 and 3 are divisible by 3. They have an x in common. So let's re-express these with 3x. So 3x times 3x is 9x squared. 3x times 1, because this is prime right here, is just 3x. Highlight the common factor as I always do, all right, so to help you see it better. So this is equal to 3x times, all right, the remaining factors, all right, 3x minus 1. So 3x minus 1 here. Again, 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. Always check. And here, 5 and 15, 5's in common, and the x is in common, so factor out the 5x. So 5x times x is 5x squared, plus this time because there's plus, and then 5x times 3 is 15x. So the common factor is 5x. So factoring out the 5x looks like this. Multiply it by the remaining factors, x plus 3, and you're good to go. All right. You can check by distributing through. It works. Okay. On the last one, 2 divides into 12 and 18, also 3, and also 6. So 6x is the GCF. So here, 6x times 3x is 18x squared. 6x times 2 is 12x. All right, factoring out the GCF of 6x looks like this. All right, so it's equal to 6x times the remaining factors. All right, 3x plus 2. 3x plus 2. All right. Now remember, just a couple notes here that this is a video, so if I go too fast, obviously back it up and go ahead and rethink it, listen to it again, and go through it as many times as you need to get the idea. All right. The next technique is the same idea, but we're going to learn how to factor out a negative or a -1. Okay. So when the lead term is negative, always factor out the negative. Let's write that down. So when, all right, the lead term, keyword lead, all right, lead term, that's the number in front, all right, or the term in front. When the lead term is negative, all right, factor it out. Factor out, all right, the negative all the time. So here we go. The lead term here is the -2x. Why? It's in front. Okay, so when you factor out the negative, let's see here. When you factor out the negative, what's going to happen here? So let me see. -1, this is -1 times 2x, and this is -1 times 4. So when you factor out the negative, all right, notice it's in common right here. All right, this is going to be equal to -1 times something, okay? What? Well, let me see, 2x, all right, plus the 4, all right? 2x plus the 4, not -4, but plus 4. Why? Well, when you factor out a negative, it changes the signs of the terms, all right? And the reason why it has to, because when you distribute back through, you get the original polynomial. All right, -1 times 2x is -2x, and a -1 times 4 is a -4. All right, don't write this down, but if you wrote this down, this is a mistake. This is the wrong way. So if you wrote down negative of 2x minus 4, this wouldn't work. Okay, you get the -2x and that's good, but when you distribute to the second one here, a negative times a negative is a positive, and it's not plus 4, it's minus 4. Okay, so this is wrong. Okay, this is a wrong way to do it. What happens is when you factor out a negative, the signs change. All right, the signs change. All right, let's get some experience here. So when you factor out a negative out of both of these, right here, a negative, you start like this, okay? And you think, okay, a negative times what is a -5x? Well, it's got to be positive 5x, because a negative times a positive is a negative. So it changes the signs. So instead of a -15 here in here, oh, I forgot to factor out the -5. I'm sorry. Let me back up. These both are divisible by -5. So we're going to factor out a -5. So -5 times x is -5x. And -5 times 3, all right, if you look here, the second distribution here, all right, gives you a -15. And it's got to be a positive 3 instead of a -3, because negative times a positive is a negative. So when you factor out the negative, the signs change. Let me write that down again. All right, the signs change. All right, anytime you factor out a negative, that's what happens. If you factor out a -3 here, because they're both divisible by -3, you start here like this. You go -3 times what is -3x? Well, obviously x, right? -3 times x is -3x. And then what here? So -3 times what number gives you 12? Well, how about a -4? Negative times a negative is a positive. And notice that the signs change from negative to positive and from positive to negative. All right, the signs change. So here on both of these numbers here are divisible by -2. So you start like this. All right, -2 times 3x is the -6x. And then -2 times 4, positive 4, gives you the -8. So you figure out what you need to distribute out or factor out, and then just distribute through mentally and figure it out mentally. Now here, all these numbers are divisible by -3. All right, so -3 times what gives you the -9x squared? Well, we know that 3 times 3 is 9, so -3 times 3 is -9. And of course, you got to have a variable in there. So -3 times 3x squared gives you -9x squared. All right. plus what? Well, negative 3 times negative 1x gives you positive 3x, because a negative times a negative is a positive. And the third one here, well, let me see, negative 3 times positive 2 gives you the negative 6. All right, so you distribute and think multiplication. All right, distribute, all right, and think multiplication as one of your methods to do that. You could write them as all factor pairs. With negatives, it looks a little ugly when you do that. Okay, I did that in the beginning here, but you can just think multiplication, all right, and make it easy on you. And that's how you distribute out a negative. All right, now last group, we're going to factor out the GCF out of trinomial. Okay, so you look at all three terms, the 2, the negative 2, and the 4, and they're all divisible by 2. So I'm going to rewrite them as factor pairs. So 2 times x squared minus 2 times x plus 4. Well, 4 is just 2 times 2. And notice that there's a 2 in common. All right, so factor it out. All right, 2 times something. All right, well, what? Well, times x squared minus x plus 2. All right, and that goes in here. So x squared minus x plus 2. And you check by distributing. 2 times x squared is 2x squared. 2 times negative x is negative 2x. And, well, guess what? 2 times 2 is obviously 4. So you check by multiplying through. Okay? All right, next one. All right, so on this one here, they're all divisible by 4, so factor out the 4. So we'll actually re-express them first. So as factor pairs, so 4 times x squared minus 4 times 2 minus 4 times 8. And notice that they have the 4 in common all throughout. All right, and you write it as 4 times x squared minus, oops, I forgot the x there. Don't forget the x in the middle. All right, 4 minus 2x, all right, minus 8, all right, and distribute back through to check. On the next one, they're all divisible by 3. So 3 times 3x squared minus 3 times x minus 3 times 9. 3 times 9 is 27. And again, look, they all have a 3 in common, so factor it out. Okay, let's finish up here. So we have 3. 3 is their common factor here called the GCF. You got 3 times something, and that is found by looking at your remaining factors. 3x minus x minus the 9. All right, that goes in here. So 3 times 3x squared is your 9x squared. All right, bring down the minus sign. 3 times x is obviously 3x. And bring down the minus sign. 3 times 9 is the 27. All right, so you always check by distributing. Always check. Let me write that down again. Always check. Make sure you're correct. Okay, now all these numbers are divisible by 5. So 5x squared is 5 times x squared, obviously. All right, 15x is 5 times 3x. And the 35, well, that's 5 times 7. So plus 5 times 7. So you re-express each as a factor pair. All right, notice that they have the 5 in common, and you factor it out every time. Okay, notice I'm repeating myself every single time because it's the same technique for all polynomials. So 5 times what? Well, let's take a look. All right, x squared plus 3x plus 7. All right, and there's your remaining polynomial. So 5 times x squared is 5x squared. That's your first term. Second term is 5 times 3x, because you got x squared plus 3x plus 7. All right, and you check by distributing 3 times because they're trinomials, okay? And that is how you factor out the GCF. Again, this is the essence of a lot of different lessons that we're going to be going through. It's a major technique that we're going to be used consistently throughout the next few lessons. All right, so you got to get good at it. All right, next step is to do your homework. All right, that's attached. So do your homework on this lesson here. And once again, it's a video, right? And you could take a look at any portion of it again by rewinding and listening to it again as many times as it takes. And of course, do your homework, check with your classmates, and then check with me later on. And I will see you in my next lesson using this technique called factoring Out the GCF. All right, this is Mr. Ainsworth. Bye-bye.